Hello, welcome back. So today I want us to look at linking processes. When we talk about process, we understand them as isolated entities where code execution happen. Here we have process A, process B, and process C, which are isolated, and they all have their specific task, which is specified to them to perform. Elixir also has a way of linking these processes together, and this term is referred to as process link. So with process link, when two or more processes are linked together, they form this special relationship. So process link plays an important role when it comes to building a concurrent and a fault tolerant application. Here we have an example of a diagram. So this diagram, we have process A, process B, and process C that are linked together. So process C, once it completes its execution, it's supposed to send a result to process B. And process B, once it receives the results from process C, it reports to process A. So now imagine a scenario where process C crash and process B is not aware of the crash of process C. So that will mean that process B and process A will continue running even with a bad state. So this is where process link comes in handy. So whenever processes are linked together, they form this special relationship. And this relationship is whereby if the process C has crashed, it will notify process B of the crash, and process B will receive the exit message and terminate. Same goes to process A, it will receive the exit message and also terminate. And this will mean by default that the memory will be cleaned up, and it will prevent the application from running with a bad state. So process link are important because it helps in shutting down part of the application or the whole application in such scenarios. But sometimes we don't need the chain reaction triggered by process link to be severe. So a severe case is whereby the whole application is shut down. And sometimes there might be a mild case where we only want a part of the application to be shut down if something goes wrong and not the whole application. So in here I have a diagram which uh, represents the web application. So we know that most of the web application relies much on the database because it needs to store information and retrieve that information whenever it's needed. So the communication between the web application and the database is done through a process. For example, in Elixir, we have a repo process which is responsible for that communication. So if this repo process crashes down, it will mean that there will be no connection between the database and the web application. In such case, it will make sense if the whole application is completely shut down. But in a scenario where, for example, here we have a message sender process. So this process is only responsible for sending messages to the user. If this process crashes, it will not make sense if the whole application is affected because we need the other process to run, even though the application is not able to send message to the users, because this can be handled separately with others. So in this case, we want to isolate a crash and not cause the whole application to crash because there's no the other processes does not fully depend on the message sender process. So Elixir has considered this, and it is possible to isolate crash. So this has been made possible by configuring a process to a trap exit. So a trap exit let me go back to our previous example. So if I configure process B to attract exit, what I'm telling process B to do is to acknowledge the exit message of a linked process, but to continue running instead of terminating. So that also should happen to process A, because the exit message should not propagate further to other processes. So task processes are one of the processes that are automatically linked to the process that started them. But not all task model functions that are available has this capability. For example, the task start does not link the process that it has started to the parent process. So we have the task async and the task async stream, which provide this capability. So let's jump to the IX terminal and see an example. So in here, I want us to check the process information that we get once a process is linked to another process. So we have the parent process, which is the IX. If I run self, you can see it that this is a process. Then I want to start another process on top of the parent process using the task async. So if we run the task async, so I want to just do a simple task by doing IO puts. So if we run the task async, there's a information that it returns. So here it returns a task struct output, and inside here we can see that we have the owner PID and the PID of the task that is started by the task async. So this owner PID matches what we have as the parent process, and this PID is the task process. The reference is the reference that you can use to monitor the process that has been started. But now I want us to check the processing, the information of the process that we are going to start, and that is the task async process. The process that we're going to start with the task async. So instead of doing outputs, I'm going to inspect the process information inside here. So it's better if I close both because I might miss that close in brackets. So by calling process info and give it the PID of the information we want, it will give us the process information. So I'll give it self. So the self in here is the PID. It will be the PID of the task process. Let me run this. Hope there's no bracket that is left out. Good. So in here we have the inspect. In here we have the inspect of the process information. And we have the task struct, which is the output returned by the task async. So inside the process information, I'm only interested with the links field. So the links field returns, the links field has the list of the process that are linked to the task process. And inside here, we can see the PID of the parent process, which is linked to our task process. So if you check this PID and you check the owner PID, they are matching. So that's it. You can explore more on the task process in the Elixir documentation. You can check on the task module that provides capability. Also, we have the task supervisor module, which are designed to be linked to a supervisor. So all functions inside the task supervisor module are linked to a supervisor, if I'm not wrong. The other example, apart from the task async and the task async stream, we also have the task start link, which link the process to the process that started them. So that's it for today. See you next time.